Hello everyone, welcome to this session. We're discussing about the sulfur dioxide as one of the non-metals. So far in the previous session, also the preparation of this, the sulfur dioxide. So today let's move on to the other part. We'll be discussing about the properties of the sulfur dioxide. So let's dive into it. Basically what we'll be talking about the physical, the chemical, and the testing characteristics or the properties of the sulfur dioxide. So let's dive into it, starting with the first part, the physical properties of the sulfur dioxide. The gas is colorless with this irritating pungent and the choking smell. So that's the normal physical property that, or just the known physical property of the sulfur dioxide. It is a colorless gas with irritating pungent and the choking smell. It is denser than air with the density of about 2.5 times that of air. It is readily soluble in water, forming an acidic solution of sulfurous acid. So those are just the physical properties of this the sulfur dioxide. Now moving on to the chemical properties. So we'll start with the acidic properties. Uh, the sulfur dioxide gas, it dissolves in water from the sulfurous acid. The resulting solution, it just turns the blue litmus paper red. So this the sulfurous uh, acid, it is kind of that solution that just turns the blue litmus paper to red litmus paper. So these reactions confirm that the sulfur dioxide is an acidic gas as due to this kind of test, the litmus paper test, as turning the blue litmus paper to red litmus paper. So it confirms that that sulfur dioxide is an acidic gas. So here's the reaction, how it occurs. Moving on, let's see the reducing properties. So we'll start discussing more on these chemical properties, starting with the reducing properties, known as the first one is the bleaching property. Now, this sulfur dioxide, it bleaches the colors in dyes such as the flower pigments and the colored paper. The reduces the dye by removing the oxygen from it, turning the compound colorless. This process can be summarized as follows. So here is how it occurs, as in how the chemical reaction, how it occurs. Now, the sulfur dioxide, it dissolves in water from the sulfurous acid. Here is the reaction, how it occurs. The sulfur dioxide dissolves in water to form the sulfurous acid. Now, then the acid takes oxygen from the dye from the sulfuric acid. Now, the removal of oxygen from the dye just converts it to a colorless compound, as you can see how the reaction, how it occurs. Now, the process is reversible, as the oxygen from the air, it can be oxidized to the compound back to its original color. So that's the bleaching property of the sulfur dioxide. Moving on, let's see the other reducing property, the nitric acid. When bubbled through the concentrated nitric acid, the sulfur dioxide, the brown films of the nitrogen dioxide gas are formed, as you can see how the reaction it occurs. Now, the nitric acid is reduced to nitrogen dioxide. Simultaneously, the sulfur dioxide is also oxidized to sulfuric acid. Now, that's all about that. Now, in terms of the other property, the reducing properties as the potassium permanganate, the sulfur dioxide, it decolors the purple acidified potassium permanganate solution. So the sulfur dioxide, it reacts with the water just to form the sulfite, then is oxidized to sulfate by the permanganate. And here is the reaction, how it mainly occur as the permanganate plus the sulfur dioxide plus the water leads to the this potassium sulfate plus this manganate plus the sulfuric acid. So of the square, moving on, the ionic equation is, as you can see, this is the ionic equation of the reaction that has occurred previously. Now the oxidation state of the manganese changes from the +7 to +2. Now this confirms that it's a strong reduction reaction. So that's the reducing property that is potassium permanganate. Moving on, let's see the other reducing properties as the potassium dichromate. So these are uh, sulfur dioxide changes the orange color of the acidified potassium dichromate solution to green. The dichromate is reduced to chromate, which is green in its aqueous state. As you can see, all of the equation and the ionic equation, how it occurs. Now, the oxidation state of the chromium changes from the positive 6 to 3, and sulfur dioxide is oxidized by the dichromate 6 to sulfate. Moving on, let's see the other reduction reactions related to this sulfur dioxide. Sulfur dioxide also reduces the various halogens. It reduces the chlorine, bromine, and the iodine. These halogens are the ones that are converted into their respective hydrogen halides. And these reactions occur in the presence of the water. And here are the reactions for the chlorine, bromine, and the iodine. Now, the oxidizing properties, talking about the hydrogen sulfide, the iron-2 sulfide and the dilute hydrochloric acid produces this hydrogen sulfide gas, the rotten egg smell, as you can feel it or you can smell it. As you can see the reaction, how it occurs. Now, the sulfur dioxide, it oxidizes this hydrogen sulfide gas into the elemental sulfur. And as you can see how the reaction, how it occurs. Now, the sulfur produces appears or as a yellow residue, and the moisture must be present as the catalyst for this reaction to occur. Now, the other oxidizing properties, talking about the magnesium, the sulfur dioxide supports the combustion of the highly reactive metals. When burning magnesium is lowered into a jar of disease of this sulfur dioxide, a vigorous reaction occurs. A white sodium, a white solid, that is the magnesium oxide, is formed. The yellow pieces of the elemental sulfur are deposited as a result. Now, here's the reaction, how it occurs. Now, test for sulfur dioxide gas. The olfactory test identified by its characteristic pungent and the choking smell. So you can test the sulfur dioxide by this test as it is identified by the characteristic pungent and the choking smell of this sulfur dioxide gas. The dichromate test, filter paper dipped in acidified potassium dichromate changes from orange to green. And the permanganate test readily decolonizes the purple acidified potassium permanganate solution. So those are the tests for this sulfur dioxide. So obviously, everyone, for this session, we've discussed the various properties of the sulfur dioxide. We've seen the physical properties, the chemical properties. Specifically, we've discussed the acidic nature of this potassium of this sulfur dioxide and the reducing properties of this sulfur dioxide. So that's clear for this session, and thank you.